When filling orbitals in a subshell, electrons will half fill all the orbitals in the subshell before they pair up. This is because although each atomic orbital can hold 2 electrons, when 2 negatively charged electrons are put into the same orbital, repulsion occurs between them. This means that energies increase slightly, meaning it is harder to put a second electron into a half-filled orbital than it is to put it into another empty orbital in the same subshell. If all the orbitals in a subshell are already half-filled, however, electrons must then pair up, as even with repulsion energy increase, the full orbital will still be at a much lower energy than the next available subshell. For example, carbon has 6 electrons. If we fill up a carbon atom with electrons based on the alpha-pi principle, we put 2 electrons in the s subshell in the n equals 1 energy level and 2 electrons in the s subshell in the n equals 2 energy level. This leaves 2 electrons left over to put in the p subshell in the n equals 2 energy level. To avoid repulsion, these would be placed in separate p orbitals, each being described as half-filled as they only contain 1 electron each. If we took an atom of oxygen, however, which has 8 electrons in, so 2 more than carbon, there are now 4 electrons to put in the p subshell in the n equals 2 energy level. Well, at first the orbitals will all be half-filled to avoid repulsion. But as there are only 3 p orbitals, the 4th electron will have to go into an already half-filled p orbital, meaning repulsion will occur. And actually, this orbital's energy will increase ever so slightly.